So for today's lecture, we're going to be going over some architecture and design patterns. I don't think this will take the whole class. So hopefully we can get you guys out of here a little bit early, give you guys a little more time to work on your projects. Okay, so we're going to go through architecture and design patterns. But first, just a reminder, oh, that should not say kickoff, but the finale is on Monday. I think it's going to be 6 to 7. Originally, it was scheduled for 5 to 6:30, so just keep an eye out for any reminders that we send to the ed discussion. And then today we're going to be talking about architecture first, so the MVVM model, and then we're going to go through two design patterns that are kind of common in Android programming. Okay, so first, MVVM. So this stands for model view view model. And this is basically how you're going to organize the structure of your app. So when you're building like bigger projects, you're going to have a bunch more screens, a lot more data and logic to handle. So this is like one way you can separate it out and kind of make it a little bit easier on yourself, whether you're implementing it with a team or if you just want it to be a little easier when you're writing tests. So we're basically going to be separating the UI and the logic within an application. And then the way you're going to do this is you're kind of going to develop the UI on its own and then handle the data flow after. So we'll get into a little bit more detail with this. Wait, I didn't realize you guys could see me the whole time. Okay, so here's like the structure. So you have the model, which is going to handle most of your data. And then this is like where you're getting and saving the data. This should be where your networking calls are handled. And then the view model, there's going to be one view model for every view. So your view is going to be like a screen. And then the view model is basically going to filter the data in the model, and that's the data that the view is going to display. So for example, with Eatery Blue, or just Eatery at this point, we have the model, which is going to get all the eateries, kind of save them. And then it also gets like your user information and saves like your accounts, your transactions. So that's why when you go to the profile page, you're able to see like what money you've been spending recently. But then if I'm on the profile screen, I don't need the eatery information because I'm not going to be scrolling through any eateries. So what my profile view model might do is just pull the user information, and that's how it's going to kind of only expose what that screen needs. So there's really no need for me to see all the eateries. So the view model isn't going to show me all the eateries. So essentially, this is all the data. This is what's going to like kind of filter out the data so that the view can see it. And then the view is going to display the data from the view model. But then you also have the user and they're like clicking on things. Maybe the user logs in. So then when the user is interacting with the app, anything that the user changes is going to get sent back to the view model, and the view model is going to update the model. So you can see that these two things are completely separate, and that's for good reason. We wanted to isolate the UI and the logic so that we can kind of dictate how data flows through our app. So we're going to go into a little bit more detail. So just the model. Again, this is handling the abstraction of data sources. So again, the view should not know that this is where like the data is coming from. Gets and saves data, as we said with like the eatery example. And then this is where like the non-visual logic comes in. So maybe you want to filter some eateries. That's probably going to happen in either your model or view model. And you can see again, like from the diagram, it only talks to the view model. So it's never going to talk directly to the view. And essentially from the model's point of view, the view does not exist. And that's one way we're going to achieve that decoupling. So next, talking about the view, this is how it's going to take in the user's actions and kind of tell the view model like what's going on. This is where it responds to UI events like button clicks. And then any user input that it gets, it again forwards it to the view model. There's no application logic in here. So this is not going to be like filtering any eateries, or this isn't going to be doing any of that kind of like back-end work. This is only to do with the UI. And again, communicates only with view model, never going to talk to the model directly. And then the view model. So it's like the mediator between the view and the model, as we saw in the diagram. It provides only the necessary data, and then it notifies the view of anything that changes from the model. So maybe in Eatery again. We weren't able to pull all the eateries at first, but now the model has all the eateries. It's going to tell the view model, and then the view model is going to tell the view, okay, we have new eateries for you to load in and display. And that's kind of how information is going to flow. And then in the other way, it also receives data changes from the view, and that's how the model is updated. So any communication between the view and the model is going to go through the view model. Okay, so this kind of brings up like, how do we handle our data and how do our UIs update based on those data changes? So what we've kind of been doing imperatively with Android Native is like walking up the widget tree with find view by ID and then changing the views manually. So we have like these set and getters. So the new way to do it, or like the way that you would learn it with Jetpack Compose, which is like a newer toolkit for Android, you're going to generate the whole screen from scratch. And then these smaller components only get updated when the data that they're holding changes. So like with composable functions, we went over this very, very briefly in lecture 1. So if this is like really confusing, it's not an issue. But like you have new functions that are like going to compose the visual elements. And then once that data inside those elements changes, like it gets redrawn automatically. So that's really how we're going to be handling data in this MVVM architecture. So some takeaways, some advantages, again, you're decoupling development and maintenance, and then it's a little bit easier to test. So you can test the UI like separately. And this is also really easy. It's better for like implementation. So you can have like one team working on the UI, one team working on the model, and it's a lot easier for you to separate out tasks. And then some disadvantages, if you're just doing like a simple project, there's really no need for like a whole new view model and view. So like with your hack challenge projects, these are kind of relatively smaller projects. It would be unnecessarily complicated to try to use MVVM, but it's good practice. And then the other thing is it's really hard to debug because declarative code is like, it would just happen automatically. So with imperative, you're kind of telling it like, this is how you update my view. But with declarative, you're just saying like, this is what I want my view to look like. And then the like Jetpack Compose handles it on its own. So it's a little bit harder to see what's going on behind the screens. Okay, so that was it for MVVM. Are there any major questions? Perfect. Okay, so now we're going to go into design patterns. So this is more like within the code, like this isn't the whole app. So we have the adapter pattern. So it helps two incompatible interfaces work together. And you can kind of convert between classes or objects. Okay, so I have a picture of the adapter because this is literally what it is. Like when you want to convert between HDMI and USB or USB-C, it looks like, you're like, if my computer doesn't have an HDMI port, like I'm not going to just rebuild my whole computer, right? Like I'm going to want to just take whatever port I have and kind of convert it to US or HDMI, which is, I should not have done that, which is what I'm doing like right now. So what we're saying is like in your app, when you have classes that you can maybe reuse, just like with a little bit of changes, that's when you would want to use an adapter so that you can kind of reuse your code and it's a little bit more flexible that way. So I have examples, but this is the overall structure. So here you have your adapter and then your adaptee. And then this is like the target interface you want to reach. So this is what you have, and this is what you want to get to. And then this is like the client. So everything you write has a client to it. Like someone's going to be using that code. So maybe the client expects a certain target interface, but you don't have that interface. So what you want to do is adapt what you do have to become that target interface. So here you can see like there's a specific request method under adaptee. And then in the adapter class, there's a request method. And then in the target class, you want to just be able to provide this request method. So how are we going to do that using specific requests? Well, basically the adapter is going to like within this request method, they're using adaptee.specific request. So we're kind of just like wrapping it in the request method so that the client thinks that whatever this adaptee is has that request method, but under the hood, it's actually just this specific request. So the adapter is like kind of just wrapping it and boxing it up so that the client is satisfied with it. Okay, so some use cases, I mentioned some of these already, but making our current application consistent with client expectations. So if the client expects something, but you don't want to change the app, this is kind of something that you can like reuse your existing code while satisfying the client's expectations. And then we would also use it when there's like a necessary outside component. So maybe like a third-party library, it has some really useful functions, but it's not really compatible with your application right now. So you can change whatever classes you need to change in your application so that you can end up using that third-party library. Because we have seen there's a lot of third-party libraries that we can use in Android that make our lives way easier, but we don't really know how they're implemented. So an adapter is a really good way for you to use that third-party library without having to completely refactor your code. And then the last reason we would use it is just so that we can reuse the code that we have in our application without needing to completely change the original code, which I kind of talked about already. Okay, so here's our example. So say you are a shop and you need more toy ducks, but you sold out. But you do have birds. So maybe you can wrap them as a toy duck. But how would we do that? So we need the bird adapter. So every bird can fly and make sounds, but what we need out of a toy duck is a squeak. So I'm going to take that bird and I'm going to use its make sound method and I'm going to call it from squeak. So then when I wrap it as a toy duck, when I call squeak, it's going to have a squeak method. It's just going to be the make sound method. So maybe birds go like chirp. My toy duck isn't going to quack, it's going to chirp. But my shop thinks it's a toy duck. So I've adapted my bird to become a toy duck. So let's take a look at the code. So just for as an example, we have like these two interfaces like I showed you over here. But so birds, they have a fly function and a make sound function, and then toy ducks have a squeak function. And then in this case, this is our target interface. So we want to change a bird to a duck. So we have maybe a sparrow. So sparrow implements bird. So sparrow has a fly method and it has a make sound method and it chirps. And now we have a plastic toy duck, which just squeaks. So these are just like classes that implement that. These are like the more concrete classes for those interfaces. So then here's our adapter. We're going to take in a bird and we're going to return a toy duck. So this class bird adapter, is going to have a bird and then it's going to override squeak and it's going to be make sound. So that bird is like calling make sound from that bird is going to be this toy duck squeak function. And then you can see over here, if we declare a sparrow and then we have a plastic toy duck, then we're going to use our bird adapter and this is going to return a toy duck, or this is of type toy duck. So I have bird adapter of sparrow. So it's going to take that sparrow. It's going to make that sparrow have a squeak method, which is just chirping, and it's going to return it as a toy duck, and it's going to be completely fine because all we required of a toy duck was that it had a squeak function, and this sparrow does have a squeak function because we overrode it in here. And then when it returns as a toy duck, everything is fine. But over here, so this is kind of like testing. I did not include the output, which is my bad. But the sparrow is going to make sound. So here, this is just going to say chirp, chirp. But then the toy duck is going to squeak, which is going to be squeak. It's going to print squeak. But then here you can see bird adapter.squeak. It's not going to print squeak. It's going to print chirp, chirp. But it's still technically a toy duck. So here's a way that we've taken code that already exists and kind of adapted it to what our client, the shop, needs. So again, some takeaways, we have advantages. So again, reusing code flexibility within an application. You can kind of incorporate previously incompatible classes. And again, you can use third-party libraries and integrate them into your code. And then some disadvantages, it increases the overhead because you're kind of like pushing it off to like the adapter to handle and then return whatever target interface you need. And then again, there's some like, it's possible that you could maybe need a chain of adapters to achieve your target interface. So again, that could be a little bit like unnecessary, a little too complex, especially if you have like a smaller project. Okay, and then our last pattern is the singleton pattern. So basically a singleton class is something where like you only want one instance of the class to be created. So like you're going to create one instance of this class and then it's going to be globally accessible throughout this app. And this app is just going to update that one instance from every single screen. It's just that one object. So every singleton has to have a private constructor, a static reference of its class, one static method, and it should be a globally accessible object reference. So we will see this in a following example. Okay, so here's like the overall structure. So this is like one singleton, and then like you can see client one, client two, client three, whatever. Let's think of those as like screens. So every screen can access this one singleton. And so maybe it would want to update this singleton. So maybe I want to have like how many, I don't know, glasses of water did I drink? But then from one screen, I can update this glass of water. And then if I switch to another screen, I want that water count to be the exact same. So that's why I would use a singleton, is so that I can kind of save that information throughout my app and then use it wherever I am. Okay. So again, here's some use case examples. If you have a cache, you want this to be a singleton because you want every screen to be pulling the same data, kind of saving the same data as well. The repository, again, saving data, you want that to be accessible throughout the app. Shared preferences, maybe you want to keep track of what the user prefers about their app. Like maybe they, trying to think. Maybe they just have like favorite colors, or there's things you want to save about this user. So like on Eatery, I know it's like you save their recent searches. But if I am not able to pull those shared preferences from anywhere and kind of use them throughout the app, then they're kind of useless. Because that's the whole point of saving the shared preference, is so that I can save it and get it every single time the user opens the app. And then I can use it throughout the app and kind of show the user that whatever they did the last time they opened the app is persisting. And then we also have seen like OKHTTP client with networking. That is also another singleton because you only have one instance of it. Okay, so in Kotlin, it's very easy to create a singleton. All you need to do is use the object keyword. So here I'm creating a repository of all my favorite colors. And I want to be able to use this throughout the app. Maybe I have just like a, I don't know, a favorite colors app, I guess. But I have a list of colors, and then I'm also saving like the number of colors that I like. So then in my different screens or my other different files, if I want to add a color, this is the function that I would call. So the only way to add a color is through this function, which is why like it's a singleton. Like you can only access it using its own static methods. So that way we ensure that it's consistent throughout the app, because I don't want to add blue on one screen and then not see blue on another screen, because that just completely defeats the whole purpose. And then we also have this get colors. It's just going to return like a list of these colors. But you'll notice that up here, this is like it's a list, so it's not mutable. But then when I change it, I am changing it to a mutable list, adding it, and then changing it back to a list. So then when I return this get colors, whoever called get colors cannot change it without using add color. So since this is a list, it's immutable. I can't add anything to it. So I'm being very careful about that when I'm designing these repository methods. Oh, okay. Well, that was the end of the lecture. Promised you guys it would be a short one. So are there any questions either about this or like the hack challenge, anything coming up? Okay, yeah. Yeah. Um, not okay. That's a good question. It's very similar to Java, but what I will say is like you know how Java has like mutable lists? Like you can just declare it like a list of colors and then you can add, remove, whatever. In Kotlin, you kind of have to like specifically say it has to be mutable or otherwise it's just going to assume it's immutable. So if I wanted colors to be mutable, I would do mutable list of. So here, just list of string. This is just an empty list. I'm not going to be able to add to it. Like if I went to Android Studio right now and I tried to do colors.add, it would give me an error because add isn't a function for lists. But when I change it to a mutable list, that's when I get the add, remove, the other functions that are associated with lists in Java. But then like down here, since I'm returning just a list, this colors is immutable. Anything else? Okay, great. Sounds good.